This is Plan Validator, a software program for independently validating scanned survey plan images or survey CAD drawings. One of the important aspects about this program is it's completely independent. It requires no CAD or GIS software and can independently verify the scan plan by computing closures, or the CAD plan by verifying the dimensions represented by text match the dimensions of the lines they represent. So let's get started. If we look at Plan Validator when it starts up, then it has a few different areas to have a look at. Across the top we have our commands. We have a map window which occupies most of the window, and then we have a plan grid for entering the information, and some status bar messages on the bottom. So let's get started. One of the ways we can, as I said, there's two ways of validating information. We can either work with a scanned image of a plan. If you don't have a scanned image, you can always use just the paper plan, but you really get the true benefit by using the scanned image for visual reference and validation. So if we open this, we can open a scanned plan. It can either be in TIFF format or it can be in JPEG. So TIFF format is sort of the standard scanning format for documents. We zoom in the map window by left-clicking on a lower left area and dragging a box into an upper right area. And we can do this as many times as necessary. To zoom out is basically the opposite. So we click on the upper right and we drag to the lower left. The size of the box will indicate the amount we zoom out. So this is the TIFF file. If we look at JPEG, one of the nice things about JPEG is it may be a little bit easier to read on screen because we can use gray shading. So if we take the same plan in JPEG, we can zoom in. See, it's a little bit clearer. We can also zoom to 1:1, which will zoom to 1:1 pixels. 1:1 pixels would be a little bit large in a TIFF file. It's pretty much screen resolution on the JPEG. Now we can just start entering the plan. So I'm going to start from this upper left-hand corner here, or the northwest corner of the subdivision. I'm going to start with my bearing. Now, bearing entry we can enter quadrant or azimuth bearings, but in this case we're going to use a quadrant bearing plan. The bearings can be entered a number of different ways. So what we can do is we can enter the bearing almost exactly as read, so 72-44-4D east, which represents that bearing, or we can enter it with the degree symbol, if you can find it on the keyboard. It's kind of tough. We can always use a caret as a proxy for the degree symbol, 44 minutes, 40 seconds east. The other way we can enter it, characters are difficult to find on the keyboard, and it'd be nice to be able to enter this entirely from a numeric keypad. So another way to enter bearings is to specify the degrees, the minutes, so 72.4440, and then the quadrant. So in this case it's northeast, so it's quadrant 1. That method can be entered entirely from the numeric keypad. So all of those are valid ways of entering the bearing. We can enter the distance. As soon as we enter the distance, we've created our first line. Now we can continue with this traverse entry. So I'm going to enter 16, and let's enter 17.54. Now, this is useful because I'm reading the dimensions off of the screen, but I want to actually use the scan survey plan to validate the direction and the location of information. So what we can do is we can reference the plan to the drawing. The way we do that is we right-click on a point and we drag it to its location on the image. And we can do this with another point, so point 4 here. we drag this to this location. Once we have two locations, we have a reference. So as you can see, now the plan is referenced to the image, and we'll move with the image as we do calculation. So as soon as I enter the next course, 39.89 or 82, it continues, and 13.73 to continue that course. So it assumes that you're continuing on the same bearing, in order to speed entry, especially on long courses along the same line. So we're going to go to the next course. So I'm going to pan down to find the bearing here, and I can just move to the bearing location, and I'm going to enter this bearing as 20, 21, 30 northwest. And I'm going to enter the distance, which is 36.82. Now we can see that the bearing is actually going the wrong way. Now, bearings by convention on some plans, in some jurisdictions, the bearings are always northeast or northwest, assuming that the line can go in both directions. But in this particular case, we're actually entering the dimension, so we need to move in the direction of the course. However, it's very easy to address this. All we need to do is in any time in the bearing field, with the minus key or the negative sign, press return, it will flip the bearing, and we'll copy the same bearing downwards where it exists in the traverse. Now we can accept the entire course. Once we get to the 2 column, that's where it actually does the computation. So it's going to recompute that. So now we're going in the correct direction, and we've created 0.7 in the correct location. So now just move over to the distance column, and I can continue on this line, 37.17, 33.84,